Hey guys, I'm Winter. Today I'm going to introduce authentication with OpenID. Before we start, I want to know how often do you forget your account name as a password for online applications? Well, in our daily life, we have too many username and password for different online applications to remember. Like you may have different username and password for your Google, Facebook, and Twitter accounts. Therefore, do we need a password management software to assist? If we need one, the OpenID could be the best choice. So what is OpenID? It's a single profile authentication, one ID accepted everywhere, an open standard, open source, not owned by anyone, but it does have a foundation that provides a legal framework, a protocol like HTTP, not an API. Google uses OpenID, so you can use your Google account to log in with YouTube, Microsoft, and so on. Its history. In 2005, the original OpenID authentication protocol was developed by Brad Fitzpatrick. 1 year later, Gene Ring developed a simple registration extension for OpenID for primitive profile exchange. In 2007, computer security company announced support for OpenID. And 1 year later, Yahoo announced the initial OpenID support, both as a provider and as a relying party, releasing their service by the end. So how does it work? Here is the architecture of OpenID. When it works, it has 11 steps. Step 1. User is presented with OpenID login form by the consumer. Step 2. User responds with a URL that represents their OpenID. Step 3. Consumer canonicalizes the open URL and uses a canonical version to request the document from the identity server. Step 4. Identity server returns the HTML document named by the OpenID URL. Step 5. Consumer inspects the HTML document header for link text with the attribute to OpenID server. Step 6. The OpenID server returns a login screen. Step 7. User sends a login ID and password to OpenID server. Step 8. OpenID server returns a trust form asking the user if they want to trust the consumer with their identity. Step 9. User responds to OpenID server. Step 10. User is redirected to either the success URL if they choose yes, or the failure URL if they choose no, returned in Step 5, depending on the user response. Step 11. Consumer returns appropriate page to user depending on the action encoded in the URL in Step 10. I know it's kind of confused. Simply speaking, we need to remember 4 main functions. End user, the person who wants to assert his or her identity to a site. Identifier, the URL chosen by the end user as their OpenID identifier. Identity provider, a server provider offering the service of registering OpenID URLs and providing OpenID authentication, like Yahoo, Blogger, and so on. Relying party, the site that wants to verify the end user's identifier, sometimes also called a service provider. To better understand, let me show you the demo. First, open up your web browser. I have already opened my Firefox. And then type Google Earth Playground. And then click the first link. Why we use it? Because OpenID Connect 1 is a simple identity layer on top of the Earth2 protocol, and Google Earth Playground is powerful and easy to use. Now we can see this is a sample application that Google created, which allows you to access the variety service that Google offers, like Blogger Books, contacts, and so on. Before I authorize the APIs, let me open my contacts so that we can compare it later. As you can see, I have two contacts here. One is Hello Network. The position is Streamer. The company is fantastic. The phone number is 120. And another is Hey Final. The position is Player. The company is Holiday. And telephone number is 0 to 1. Now, let me come back to Arts Playground. Choose Authorize APIs, which authorize the end user, me. Now it asks me, Google Earth 2 Playgrounds would like to have offline access. And let me choose Allow. Now you see, it gives me a unique authorization code. And the button below said, Exchange authorization code for tokens. And let me click this button. Authenticating the user involves obtaining an ID token and validating it. ID tokens are a standardized feature of OpenID Connect, designed for use in sharing identity assertions on the Internet. So, this process is actually what web application does. It gets a code and takes the code and sends back to Google. Here we can say access token, token type, expires in, refresh token. Finally, call the application we want to use the token. We can just simply choose List Possible Operations. I want to show all my contacts, so I select List Contacts. And then I send the request. Okay, here we go. This is my name and my email address. Here we can say, this is one of my contacts. Hey, Final. The company name, the position. And we can also find another Hello Network contacts. And that's it. Why we use OpenID? There are a lot of benefits. For website benefits, it increased conversion rates from site visitors to registered users. It reduced customer care cost and frustration with forgotten passwords. It accelerated adoption of community features. It limited password sharing issues. It facilitated single sign-on across multiple company and partner websites. For user benefits, it faster and easier registration and login, reduced frustration from forgotten username and password, maintain personal data at current and preferred sites, minimize password security risks. Now we know, if you use OpenID, the global URL is your unique identity. It's very convenient. You don't need to memorize lots of passwords. However, it also exists security issues. Can all OpenIDs be trusted for really critical logins? If there's a security breach due to OpenID, who is the consumer going to blame? Probably the biggest concern with OpenID is phishing attacks. Users may be tricked into providing their credentials to phish the OpenID provider website. What are worse, users then lose their accounts for all the service associated to OpenID. And second, relay attacks. the URL from the relaying party can be sniffed, analyzed over HTTPS, and as such being replayed. CSRF, cross-site request forgery. Once the victim is logged in malicious, user might be able to execute CSRF attacks against other sites. XSS. When the user is logged in, attackers might be able to execute a series of cross-site scraping attacks against the identity provider, in which case they will be able to hack the entire online use presence. And this is a reference. Any questions?